Hi guys, we have a question here that says a tennis ball is projected horizontally from the top of a vertical cliff 50-meter high with a velocity of 10 meters per second. Let's represent this information in form of a diagram. So this is what the information is all about. This is the vertical cliff 50 meters high, and this is a tennis ball that is projected horizontally with a speed of 10 meters per second. So the ball moves off in the horizontal direction at this speed. However, gravity will be acting on the ball. So as it is moving forward, it is also falling down. Hence, we have this projectile motion, or this motion along this parabola. Now, if you look at this motion, there are two independent motions. A constant horizontal motion and a changing vertical motion. A constant horizontal motion, because this initial speed of 10 meters per second is not changing. It is a constant speed. Once it is released at 10 meters per second, that speed is constant in the horizontal direction. That is because there is no force acting on the tennis in the horizontal direction. The only force that could be acting on it is air resistance. But in questions like this, we normally neglect the air resistance. So this ball is not acted upon by any force in the horizontal direction. So this speed does not change. It continues to move in the horizontal direction at a constant speed of 10 meters per second. However, vertically, gravity is acting on the object. Because gravity is acting on the object and gravity acts in the vertical direction, the object tends to slow down. The object tends to fall to the ground rather than continuing in its horizontal motion. And that is how it hits the ground at this point. So we have two independent motion, an horizontal motion at a constant speed and a vertical motion due to gravity. So let's look at some of the questions under this diagram. The first question says, find the time taken to reach the ground. If we look at this question, it's talking about the time to reach the ground. And to get to the ground from the top, it means it is acting under gravity. So we are going to consider the vertical motion independently of the horizontal motion. So in terms of the vertical motion, we can say that the distance covered, which is s, in this case, that is the height of the cliff, equals to ut plus half gt squared, where g is the acceleration due to gravity. So the distance h, this is supposed to be h because it's height instead of s, is 50. Initially, for the vertical motion, the object is appearing to be at rest. So it's as if it is released from a height. So the initial speed in terms of the vertical motion is 0 plus half g. G is 10 times t squared. We are looking for t. Half of 10 is 5. So this reduces to 50 equals to 5t squared. To obtain t squared, we divide both sides by 5 so that t squared is equals to 50 all over 5, and 50 divided by 5 is 10. T equals to the square root of 10 when the square crosses over. So t is equals to square root of 10 seconds. So this is the time taken for the tennis ball to hit the ground. I'll leave it in the solid form so I don't go into decimal fractions. So the time taken is square root of 10 seconds. The negative value of t is not needed because time cannot be negative. So we have the positive value of root 10 seconds. Now let's look at the second part of the question, the vertical component of the velocity when it hits the ground. So this vertical component of the velocity, what would be the value of the velocity at the point where it hits the ground, the vertical component? Again, we are considering the vertical motion, so it will be the motion under gravity, which is also independent of the horizontal motion. So we can say v equals to u plus gt, where v is the vertical component of the velocity, u is the initial velocity, which is 0 for the vertical motion because as if the ball is released. So if we put the values, we have v is equals to 0 plus 10 for g times root 10 for the time taken. So that the vertical component of the velocity v is equals to 10 root 10 meters per second. Now the third one says, what is the distance from the foot of the cliff where the ball hits the ground? It's asking for this distance here. The distance from the foot of the cliff to where the ball touches the ground. If you look at this distance, it is talking about the horizontal distance. So at this point, we can now consider the horizontal velocity, which is independent of the vertical motion. So now we can now bring in the equation of motion that we use this vertical velocity because, sorry, this horizontal velocity, because we are talking about the horizontal distance. And remember, this horizontal velocity is constant, which means it is not being acted upon by any force, or it is not accelerating. So if you're solving this problem, you will need to ignore the acceleration, but you will calculate the distance. So try this number 3 question out and put your answer in the comment section. I hope you all enjoyed this video. Thank you very much for watching. Please endeavor to share this video to others so that you keep encouraging us to make interesting content. See you in our next video.